Hi, my name is Talia, and I am an incoming high school senior. I'm super passionate about chemistry and math and helping others. And I started this YouTube channel as a way to connect with students who may be having difficulty in their chemistry classes and just want a supplemental resource to help them better understand whatever they may be learning. I've been going in order of the topics that I learned in honors chemistry, and today we are going to be working on learning density. I'm going to go over the subject, and then we're going to do a bunch of practice problems. In my previous video, we went over temperature conversions, and all things significant figures. So feel free to watch that if you need help with that. But without further ado, we are going to get started on our video for today. All right. So we are going to get started with density. So in terms of definition, density is just the mass of a given volume of matter. And you can calculate it using these equations. So density is mass over volume, volume equals mass over density, and mass equals density times volume. And you can also solve for each of these equations using any of them, really. You can get from one equation to the other very easily. So like, let's say I wanted to turn this one into this one. I would just divide both sides by density, and these cancel out, and I just have volume equals mass over density. So in these equations, D represents density, which can be in grams per milliliters or grams per centimeters cubed. And if you remember from our metric conversions and non-metric conversions, 1 milliliter is equal to 1 centimeter cubed. M represents mass, which is in grams, and volume can be in milliliters or centimeters cubed, similar to density. And you can also use density to obviously determine relative density, which just means like how dense one object is in comparison to another one. So relative density can be determined by flotation. Basically, if one object or one substance floats in the other one, its density is less than that of what it is floating in. Okay, so now we're going to try some density calculations. Please try these on your own. You can pause the video and then meet back up with me when you're done. Okay, so we're going to move on to the solutions that are down here. For the first problem, the rock has a volume of 15 centimeters cubed and a mass of 45 grams. We want to use the D equals M over V equation. So we're just going to divide 45 grams by 15 centimeters cubed to get 3.0 grams per centimeters cubed. And remember that you want two sig figs because 45 and 15 both have two sig figs, and with multiplication and division, you write your answer in terms of the number that has the lowest amount of sig figs, like the number that you're given. The second problem, you are doing virtually the same thing, dividing 60 grams by 30 centimeters cubed, mass by volume, to get 2.0 grams per centimeters cubed. Now, the third question is two parts, and these are crucial differences to understand: heavier versus more dense. Heavier just solely relies on mass. It is just how much matter you have, versus more dense means how much matter you have per, like in proportion to the volume. So if a substance is more dense than another one, it means that if the two substances had the same volume, substance one would have more mass in that volume than substance two. So knowing that, we can go about these two questions. I wrote them separately. Rock 2 is heavier because it has a higher mass of 60 grams, and rock 1 is more dense because it has a higher density of 3.0 grams per centimeters cubed. And that is pretty straightforward. You just have to make sure you're using correct vocabulary with these concepts. Just remember, heavier is more matter. There's more stuff in it, and if you think about density, it's just more mass per volume. So hopefully that helps with your understanding of heavier versus more dense. We are now going to try one more problem. So a graduated cylinder is filled with 70.0 milliliters of water. When a rock of platinum that weighs 300 grams is dropped into the cylinder, the water level rises to 98.2 milliliters. Determine the density of platinum in grams per milliliters and kilograms per liters. Okay, so our first thing to do is we want to determine the density. And to do that, we need mass and we need volume. So we have mass, the block of platinum weighs 300 grams, but we have two volumes. We have 70 milliliters and 98.2. And it's kind of confusing to figure out which one to use. So we know that the block of platinum was put into the graduated cylinder and the water level rose. That means the volume changed by the difference between these two volumes. Therefore, if you subtract the final volume from the initial volume, you will get the volume that the block of platinum has, because that is the amount that the volume rose by. So what we are going to do with this is subtract 98.2 milliliters minus 70.0 milliliters, and then our answer would be 28.2 milliliters. And again, that is because the water level rose by 28.2. So we went from, I'm just going to abbreviate, graduated cylinder plus platinum minus graduated cylinder, we get just the volume of the platinum. And I feel like that kind of helps with explaining it more. So now we have volume and we have mass. So now let's find density. So we have density equals mass over volume. Okay, so we can plug in the mass, which is 300 grams over 28.2 milliliters. And we get 10.6 grams per milliliters. So now we have our density in grams per milliliters. This could also be written in grams per centimeter squared, but because our volume was given in milliliters, I wrote my density in milliliters, just because that mathematically makes sense. If you're given a volume of 1 unit, don't switch it in your calculation unless you show that you are converting from one unit to another. Now we're going to do the final part of this where we convert to kilograms per liters. And I'm going to do this in a one-step conversion. So we have 10.6 grams per milliliters. We want to first eliminate the grams and get it to kilograms. So we have 1 kilogram is equal to 1,000 grams. And then we want to get to liters. So 1 milliliter is equal to 1,000 liters. Now these units cancel, and we have kilograms per liters. If you don't understand how to do this conversion, feel free to refer back to my first video. So now just plug into your calculator, keep the unrounded version in your calculator, and just hit the divide button over here. Divided by 1,000, divided by 1,000 again. We get 1.06 times 10 to the negative fifth. And that is kilograms per liters. Okay, so we are going to keep going with our density calculations. We have here the density of sugar is 1.4 grams per milliliters, and then the sides of the sugar cube are 1.30 centimeters. So we want the volume in centimeters cubed, milliliters, and liters. Okay, so there are multiple steps to doing this problem. For the first part of this problem, we don't need the density. We are just going to find the volume by just doing 1.30 centimeters times 1.30 centimeters times 1.30 centimeters, because volume is length times width times height. And then I'm just going to plug that into my calculator, and I get 2.20 centimeters cubed. And we want to round up, so 2.197. Use the 7 to round the 9 up, but that rounds it to the next 10 to 2.20. And then we are now going to use that volume and this density to determine the mass of the sugar cube. You cannot use the 1.30 centimeters as your volume, because that is not volume. That is the measurement of the sides of the sugar cube. We need it in centimeters cubed or milliliters to convert and get mass. However, before we find that mass, we need to convert our volume to milliliters and liters. So we're just going to do that. 2.20 centimeters cubed times 1 milliliter is equal to 1 centimeters cubed, which we already know. So we would get 2.20 milliliters. To convert to liters, we have 2.20 milliliters times 1 liter equals 1,000 milliliters. So you can just divide by 1,000 and get 0.00220 liters. Now, with finding the density, you always want to make sure that your units match. So if we have milliliters in our density, we want to use our volume that has milliliters in it, because the units need to cancel out in order to just leave grams. And that makes sense. It's just like when we were converting, we wanted to make sure the units canceled, except this is a little bit different. So just make sure your units are the same. Don't use centimeters cubed. To find mass, we want to do mass equals density times volume. So the mass equals 1.54 grams per milliliters times 2.20 milliliters, not centimeters cubed. So I'm just going to go back up in my calculator and use the unrounded version to get 3.38. And if you were to write this out like 1.54 grams per milliliters times 2.20 milliliters, these milliliters cancel out and you're just left with grams. So that is that problem. Now we're going to move on to our next problem. We are determining the mass of the sample with a given volume and we have the density. So this is just a simple mass equals density times volume. So we're going to do 0.800 grams per milliliters times 65 milliliters, and the milliliters cancel out to just get grams. But you need to plug that into your calculator, and we are just going to get 52 grams. Again, we want 2 sig figs because that is the smallest number of sig figs in our givens.
So that was this week's video on density. I hope you enjoyed and that you were able to learn something new and get some extra help in what you're learning in chemistry. Please let me know if you have any questions in the comments and I will do my best to answer them. Next week, we are going to be moving on to a whole new unit. So if you need help with things with basic periodic table characteristics, you are welcome to join me back to watch upcoming videos. I hope you enjoyed the video and good luck with learning your chemistry.